and you take internet for granted, but it works because somewhere in the layers that implement the internet, in one or more places, you have some kind of fault tolerance implemented. Okay, what can you do about faults? So two of you, you haven't used the RAMCT, so take a look at, so try logging into RAMCT and see if you have any problems. But it's, once you have figured it out, it's fairly straightforward. But you may want to play around a little bit and see what you can see there. And now we also have a discussion board there. So if you have any questions of general importance, general interest, you can ask them on our discussion board. If there are some specific questions, you can just ask me, send us an email, or just talk with me personally. But if anything that is of more general interest, you can share in the discussion board. Okay, so what can we do about faults? Fault detection. So there's fault detection. So the question is the fault there or not? So sometimes we are interested in just the fault detection. So there is a chip that is not working. And if it has a fault, we want to throw it away, otherwise not. So sometimes this is the question we want to ask, fault detection. But sometimes we are interested in a little bit more detail. If the fault is there, where the fault is. So for example, if it is a single chip which has a fault, maybe you want to throw away the fault, throw away the chip. But if you have something wrong going on with your PC, maybe you don't want to throw out your PC. Maybe you want to figure out which particular thing, maybe there's a particular memory chip that is bad, and then maybe you can replace it. And so you may want to do fault location. Sometimes you want to do fault diagnosis. Sometimes you want to decide which particular fault it is. So there's in a certain place there's a fault, but what kind of fault it is. Later on we will see faults of different kinds. A lot of time we will simply consider the fault detection problem. So these things will take more work. And sometimes that work needs to be done, but sometimes we don't have to do that work. But this is fundamental. Okay, automatic handling of faults. How can we handle faults for a fault is encountered? One is we can do some kind of fault containment. Contain the effect of the fault. So somehow block error flow. So there's a fault and it causes some error that is flowing in the system. Somewhere you block the error from flowing. That is fault containment. And sometimes you can have some scheme which can simply mask the effect of the fault. So the fault doesn't have any effect. And of course, if you want to do fault masking, it is going to cost you. It is going to take you extra hardware perhaps, but in some cases you have to pay for the cost. And fault recovery. Somehow you have to get back to correct operation. So mechanism for recovering from a fault. So these are the things you can do regarding a fault once a fault has been encountered. Okay, and next let us look at the reliability measures. Uh, Okay, before we do that, I think we still have, what, about 10 minutes, or is it 5 minutes? Actually, I forgot to synchronize, check my watch and see how far it is from actual time. What time do you have?
10:34, so we have like 10 minutes.
Okay, so we have about 5 minutes, okay? Or maybe we're going to take it a little longer. So let's do it next time, in introduction. So find out about what you are interested in and what is your background. So we'll do it next time. And let's continue with reliability measures. Now, some of these things we are going to come back and look at in more detail. So this is kind of an overview of what the course is about. Here are some reliability measures. Failure rate. Okay, how many of you have come across the term failure rate? Okay, how about, have you come across MTTF, mean time to failure? So this is, oh, something happened there. Oh, I didn't charge the laptop enough. So it's, oh, I should have brought my, well, that's okay. Not a problem. I can just write on the board. Somehow I thought it was fully charged, and I guess it wasn't.
I guess this is a good example of the mean time to failure.
Yeah. Yeah, so this is, yeah, I think it holds its, it should hold charge for longer than, I guess 1 hour, 15 minutes, but maybe I hadn't plugged it in. So, okay, so let's go back to the good old board. And we will turn this off. Most of the time, I'm planning to write on the board. Occasionally, I will use slides, but mostly I will write on the board. And so failure rate is one of them. Now, you will see the term failure rate used for both hardware and software. And we can define failure rate as fraction of units failing per unit time. It is actually possible to come up with a more rigorous definition, more mathematically precise, but right now an informal definition like this is enough. So let's say we had 1,000 units, and let's say 3 of them failed in 2 hours. Then what can we say about the failure rate? So we had 1,000 units. And 2 hours, and 3 of them failed, so that is 1.5 multiplied by 10 raised to minus 3 per hour. Now, incidentally, in these calculations, there are a couple of things that are worth noticing. Remember, whenever you say rate, whenever we use the term rate, that means it will have the units per unit time. That's why it is a rate. And you have to be careful about it is per unit, which is the unit of time that is being used. Because in this case we are using hours, so this comes out in hours. Sometimes the rate may be calculated in seconds or some other units of time. And also other thing you should notice is that one common mistake is to have correct powers of 10, which is actually powers of 10 are now very important. And so for example, if you take powers of 10 for amounts of storage, so you have, you used to have, for a computer, you used to have megabytes of main memory, and now sometimes you have gigabytes. Or for if it is a hard disk, it is, now you have gigabytes, and if it's big enough, maybe it's a terabyte. So powers of 10, very important. You have to make sure that it's correct. Any questions on this? Now there's other one, mean time to failure, which is actually more popular. And it is actually popular enough that a lot of people will recognize the abbreviation MTTF. It is the expected time before unit fails. Okay, now mean time to failure and failure rate, they have a connection. And can you guess what the connection would be? So very important connection, and we will discuss it next time. But they have an inverse relationship. So we will continue next time. And so that's it for today. And any questions? Now here, some of these things we are going to come back and look at in more detail, and we will look at them more rigorously. But right now, we want to look at some of the basic things, basically to get a perspective. So next time we are going to talk about different types of redundancy. So that's for next time.
The slides will be available online today?
Yeah, the slides will be available online. So I will, sometime during some discussion, I will make the slides available. Perhaps not at the beginning, but sometime during the middle. So let's see. Yeah, let me put the slides on the web. So let me put a link to these slides.